I get to talk about how we're going to transform every university in my membership into a speed of business organization. But we've been trying to tackle talent problems for many years, including one that I think everybody in the universe jumped into, which was increasing the number of STEM graduates. And so we organize ourselves internally into working groups. We have CEOs and university presidents working on this. So everybody around about 2006 or 2007 jumped onto the double the number of STEM graduates bandwagon. And so the chairman of our, or the co-chair of our STEM initiative was Bill Swanson, chairman of Raytheon, an engineer, obviously, who in a very engineering way said, do we even know enough about the nature of the problem and to identify high leverage solutions? So he went back to his chief engineer and asked, can we use the tools that we use for our customers to better understand this STEM problem of P16 and into workforce? And so we launched a 3-year system dynamics modeling project where we really were working with rocket scientists from Raytheon to use Forrester's system dynamics model to model a nonlinear system, this thing called education. And so we built a model that could lower the attrition rate of highly effective math teachers and see the effect on the number of 12th graders who graduate college-ready in math, and some of them go into STEM majors, and a portion of them finished. But the most interesting takeaway, if you've ever been part of that community, you realize that most of the buzz is about K-12, and you can never start early enough in the K-12 system. The model proved that the highest leverage point in the entire P16 continuum is the first 2 years of undergraduate education, where we drive 50% of students out of STEM majors. And at the same time, we were doing workforce modeling that convinced us that we could never, at the rate we were increasing the number of STEM graduates, we could never meet the demand in the economy for STEM skills. And just one data point, almost 50% of engineering graduates go into non-STEM fields, non-engineering fields. Goldman Sachs employs 9,000 engineers. And that's just one indication of the demand in the larger economy for STEM skills. And so the big takeaway for us, even though our whole initiative was about increasing STEM graduates, is that it's not really about STEM graduates, it's about STEM skills and STEM talent, much of which can be found in non-STEM degrees. And so let me talk about our initiative to focus on that. Okay, so as I said, we're a 40-year-old organization of CEOs and university presidents. And what we try to do is work on this talent issue. And so we do it through building partnerships, first with our own academic and business members. We strengthen talent by focusing on skills, and I'll get into some detail about that. And what we try to do for a larger audience is to identify actionable insights. And so we'll go through this fairly quickly. Oops, if I can figure out how to change the slides. So our work in both college readiness, which was another initiative, and with STEM, allowed us to get inside a whole series of components of this talent ecosystem, the demand side, the supply side, and develop a pretty rigorously tested methodology for understanding what the talent needs are, how to communicate them to faculty and administrators at universities, how to get them to move more at the speed of business, and how to create a positive feedback loop among all of these. So let me walk you through them. So we've done a lot of work with Burning Glass Technologies that has a scraper and creates a massive database. They read about 100 million job applications a year. So we've gone through sectors and asked them to identify the data science demands in, for example, financial services across the country, but also in the New York City region. So we know the number of jobs that are posted, we know what the job titles are, we know what the skills are, we know what the salaries are, we know how long the jobs have been open, et cetera. And it's a pretty clear demand signal. Now, we don't know that all those jobs are filled, but we do know that it's at least some demand signal. We then work with business to get inside those demands and create the ideal candidate profile. And I'll talk about that in a larger context. We then work with the academics to map those characteristics, what the business folks call competencies, into learning outcomes within existing courses, for example, in systems engineering or other areas. And then do a gap analysis. Where do we need to add components? Where do we need to add new courses? Where do we need to change capstone projects? Select the credential, whether it's a major, minor, concentration, certificate, whatever. Integrate high-impact practices, research-based, research-proven practices to increase learning and persistence, and basically develop a positive feedback loop. So here's basically what we have been able to work on. In talking with our members, thinking we were really looking to increase the number of STEM graduates, we really discovered a new hybrid economy. We discovered the fact that there were a whole series of emerging fields that were beginning to transform innovation, companies, and the economy that are not currently reflected or were not currently reflected in undergraduate education at the time. So there are fields like data science and analytics and cybersecurity and social mobile, a whole series of these new fields. And virtually no undergraduates were exposed to these fields. And those who were upper division students within STEM. So only basically junior and senior CS students could take electives in data science and analytics. But they had a whole series of prerequisites. So first of all, you didn't find out about them until your junior or senior year. And if you didn't have the forethought to take all of the prerequisites, you couldn't have access to it. So it gave us an opportunity to think about partnering our members in really different ways around transforming the undergraduate experience. First within the STEM majors, but it became very clear to us that the demand was way outside the bounds of that. We really focused on developing a strategic engagement model for business and higher ed. Those partnerships have been very tenuous, they've been very transactional, and we've spent a lot of time transforming those into deep, long-term relationships that provide high ROI for both parties. We've secured a $4.5 million grant from the National Science Foundation to establish the Undergraduate STEM Interventions with Industry Consortium. It's both an implementation and a research project that supports 5 different partnerships, including those focused on data science and cybersecurity. We've launched, with the Burning Glass data, a financial services industry workforce project to understand the broad demand across all functions within financial services for some level of exposure to data, analytics, or the pure data science. We got funding from the Sloan Foundation to create the New York City Data Science Task Force that have enabled us to map competencies, and I want to show those to you in a minute. We're working in cyber in the DC region, and we have our own internal national cyber and data science working groups. So through our first phase, we've been able to identify these fields. We've created partnerships, proof points. We've got about a dozen different programs underway at universities, new types of programs with business partnership supports. But we really want to push the envelope and move into thought leadership and market intelligence to influence a larger audience. We think we've learned a lot about aligning higher ed with business needs and it's not just business, it's government, nonprofits, and for-profit organizations. There's a fundamental, as you know, you're all here, there's a fundamental transformation underway. Data has transformed virtually every large organization into data-intensive and analytics-intensive enterprises. What we're trying to do is capture that here. We want to serve as a hub for national competency maps. We want to publish cutting-edge research with our partners IBM and PwC, facilitate the development of industry-recognized credentials and pathways. And the last one I think is very important because it's the most expansive view of this. Just as data has transformed most large complex organizations, our goal is to transform the undergraduate experience and expose virtually all undergraduates to data and analytics. We see it as a new form, a 21st century form of quantitative and computational literacy to which all undergraduates, regardless of discipline should be exposed. So here's what the task force has been able to do in about 2 years: identify and map the competencies. We're working on developing a repository of undergraduate data science resources. We're raising money to seed undergraduate programs in response to what I'm about to show you. To establish an accessible menu of high-impact learning experiences, and disseminate learning through national convenings and particularly reports. But I want to focus on the what we think can be a very significant contribution in this effort. So we've done a series of workshops in New York, attracting business representatives from around the country, about 30 plus business representatives and 50 experts to work on this hierarchy. This basically has been given to us by the Department of Labor and other organizations. But the real contribution here is to focus on the academic competencies for the first time and to really begin to drill. There's much, much more behind this. I can't go into all of it. But it's really a very systematic way to think about how undergraduate experiences provide personal effectiveness competencies, how the new experiences in data science can build these academic competencies. We think there's a real need for experiential learning, some of it in workplaces, to build the next tier of workplace competencies. And the top tier are really sector-specific applications, technical applications within sectors. And so, for example, if you're in the health sector, you have different data, you have different regulatory environments, you have different ethical challenges, you may use different tools. And so there are sector-specific. What's really interesting is we entered this whole exercise anticipating that the academic competencies would be really different depending on the companies and the sectors, and it turned out that they're not. They're looking for foundational competencies across sectors. So the next step is to deploy this competency map. We're looking for higher ed to map this into the existing relatively small number of curricula. But more importantly, to use it to develop new educational courses or programs, explore the application across multiple disciplines to try to break down the stovepipes within higher ed, and offer feedback to BHEF and our partners on the adoption. What we're really doing is building a community here within higher ed around curating these competencies. I think there's a slightly bigger opportunity with business, not only to prioritize the project and employees linking them to business and research activities, but begin to look down into their own organizations and identify job families that use these. One of the really great opportunities we have not only is to have them tell us what competencies are missing, but to really begin to take a critical look at their own talent acquisition strategies. Because the more we embed these data science skills across a range of majors, these talent pools are going to be found in different places. And so we're challenging our own BHEF members to examine their talent acquisition strategies and begin to evolve those strategies to capture new talent. I'll give you a really good example. Northrop, it's actually in cyber, but Northrop Grumman and West Bush, its chairman, is our member, partnered with the University of Maryland College Park to fund an interdisciplinary undergraduate honors program in cybersecurity that attracts students from all over the university. So these are business majors, criminal justice majors, psychology majors, et cetera, philosophy majors, et cetera. The majority will be CS or CE. But as companies put together interdisciplinary teams to solve problems, especially on the cyber or the behavioral data science dimensions, they're going to need to attract talent that don't look like the systems engineers or the computer scientists to be part of really diverse teams. That's going to take a really different talent acquisition strategy. And so we're starting to work with our member companies to work on that right now. I think we've got some, and by the way, you can't read all of this necessarily, but I hope can make the slides available to participants here. But we've got some. Okay, so the two reports that you see up on the right-hand side, the covers, those are case studies on how we have worked, on the one hand, with Case Western Reserve University to create an interdisciplinary minor in data science, and the second is Drake University that has built a whole series, 5 or 6 or 7 different data analytics-rich concentrations and pathways in data analytics and actuarial sciences, et cetera, and business across a whole range of. So we're going to go deep with our members on this. There's a burning glass analysis coming out soon. We're commissioning a Gallup survey of 200 global CEOs and 200 provosts to understand the current state and future state, desired state of data science, and we'll be producing a report with PwC this winter. And we are piloting DSA course modules for the enabled graduate with the publisher Wiley & Sons to make those course modules available so that every campus doesn't have to invent this themselves. And save the date, we'll be doing a webinar on the DSA undergraduate competency map release there. And tomorrow there'll be a roundtable discussion to really dive deep into this. But let me stop there.